In this lesson, I'll show you how to implement idempotence for your REST API to make sure that when you send a duplicate request to your API, it doesn't cause additional side effects. This is very common when sending the same POST request multiple times because the POST HTTP method and the respective implementation in our code are typically not idempotent. Here's a quick reminder about idempotence from one of our first chapters. An HTTP method is idempotent if multiple requests using the same method have the same effect as a single request. For example, the getHTTP method is idempotent because retrieving data from your API shouldn't create any side effects in your system. A POST, on the other hand, is not idempotent. Let's take a look at our example for creating an entry. If we were to send the same request multiple times, then we would end up creating multiple entries. Here's a diagram of how we are going to implement support for idempotency inside of our API. The client is going to generate a unique value. A good option is a version 4 UUID, and they're going to include it in the idempotency key header. So let's say we send a POST request to the entries endpoint, and we include the idempotency key and our request data. We're going to create a resource and return back 201 created. Now let's say a duplicate request comes in and it includes the same idempotency key. We're going to cache this value temporarily, and in this case we're going to recognize the duplicate key, and we can just return 200 OK and the previous response. We can also return the same status code without the response body, and this should also cover any invalid requests. For example, we run into a validation problem. In that case, we would want to return a 400 status code. Now, what happens when the key expires? Well, in that case, you have two options. First, you can either store these keys forever, which means that they do not expire, or you can store them for a given period of time, let's say 1 hour, 1 day, or whatever you think makes sense for your system. But let's say that this time has passed and the key expired from our cache where we were storing the idempotency keys. In this case, we would just process this like a regular request and return back 201 created. So this is the option that I'm going to implement in the code. Now let's discuss how some other popular companies solve this problem. Here's an example from the Stripe documentation, which supports idempotency in their APIs. They require you to provide an idempotency key header, which should contain some globally unique value. As I said, a version 4 UID is usually a good option. Now, when it comes to the specifics of how Stripe supports this, you will see that they store the idempotency keys for 24 hours. After that, they expire, and if you send the same key again, it's going to be treated as a new request. Now, you have to ask yourself, what type of problem does this solution actually solve? Well, this is mainly meant for some sensitive endpoints where executing the same request more than once is going to lead to some very large problems. Stripe is a good example of this because they are a payment provider. If you send the same payment request twice, where the second one is by accident, then you're going to end up with some very unhappy clients. So this is really meant for mission-critical endpoints, where executing something exactly once is a strict requirement. Now, another problem when this can happen is network timeouts. You could send a request to your REST API, and let's say it takes a long time to process. You might run into a network problem and you think the request failed, but it's still being processed on the server, and the server processing may even complete. But because of the network failure, you decide to retry the request and you will effectively send a duplicate request. I think this is very important to understand. This is the kind of problem that this solution solves. I don't think it's a good idea to use it as a general purpose solution because it adds overhead to your application and it also introduces complexity, and you will probably be better off by implementing natural idempotency checks in your code like we did for the duplicate tag names. Now let's jump into the code and I will show you how we could implement something like this. As this is again a pretty low-level solution, I didn't want to write all of the code from scratch. Instead, I added the solution behind the scenes, and you can grab the source code from right under this video, and I'm going to comment on the implementation. So the approach I took was defining a custom attribute, and I'm also implementing an iAsync action filter inside of this attribute. The attribute is called the idempotent request attribute, and here I'm going to extract the idempotency key header, try to parse it into a UUID, a GUID in C#, and see if we've already seen a request like this in the past. I set the default cache duration for my idempotency key to be 60 minutes, and I'm not using a proper cache, I'm just using in-memory caching. If you want a production-ready solution, you definitely want to consider using a real distributed cache. Now, with these remarks out of the way, let's check out how I implemented this. In the onActionExecution async method, I'm going to check the request headers to see if the idempotency key header is present. I'm going to then try to parse this value into a GUID instance, and if I get my idempotency key, then we can continue with the execution. Otherwise, I'm going to return a 400 bad request and say that we have an invalid or missing idempotency key header. Then I'm going to resolve the iMemory cache from my services. Again, the remark about using a real distributed cache in production. After I get my memory cache, I'm going to generate a cache key and use this cache key to obtain a status code. This is just going to be an integer value, and if it's not null, then I have a cache hit, and I just want to return a status code result, including the original status code. Otherwise, I'm going to execute my action by awaiting the action execution delegate, and this will give me back a result object. And if this is an object result of any kind, then I'm going to store the status code of this object result for the default cache duration. Now, how do you actually apply this? Well, inside of the entries controller, I added the idempotent request attribute to the create entry post method. So now let's start the application and test this out. So I want to send a post request to the entries resource, and I'm going to include a version 4 UUID as my idempotency key value. But first, let's send the request without the idempotency key. If I click send, I will get back a 400 bad request response saying that there is an invalid or missing idempotency key header value. Now let's include the idempotency key header and send another request. We're going to land inside of our action filter, where I'm going to parse the idempotency key, and we're going to check if we have this value in the cache. You can see that it's null, so I'm going to execute my endpoint and cache whatever status code I get back. So let me press continue, and you can see we get back a 404 not found response because the habit with the identifier that I specified in the request body doesn't exist. Now, if I were to send this request again, we're going to land on the same breakpoint, but this time you will see that the status code is present in the cache. So I'm going to return this as the result of this request, and we'll get back a 404 not found response. So this is how we can implement idempotency. Now I'm going to modify my request to include a habit ID that does exist, but this time I'll need to update the idempotency key header. So let me just change this value here. I will send this request again, and you can see that we get back a 201 created response with our new entry. However, if I were to send this request with the same idempotency key, then I'm going to get back my cached result. So we just get back 201 created, but there is no request body and there is no location header present in the response. Now we could additionally implement caching for the location header and the response body, and also return that in case of a cache hit, but that is just going to complicate our solution. However, if you wanted to do this, then you could, inside of this step here, you would just need to cache an object instead of the status code like I am doing. So this is a simple way how you could implement idempotency support in your REST API. There are a couple of more things that you should add to your solution to make it production ready, but I want you to really consider if this is something that your API needs. There are better ways to implement idempotency, like we implemented it when creating tags and explicitly checking if a tag with a given name exists. You should ask yourself, what is the use case for someone sending a duplicate request? Is it intentional, where they may really want you to create two resources, or is it because of a network failure and then we end up with redundant data? Can we also fix this problem? For example, we could just delete one of the resources and the system will be back in a correct state. The only situations where this is really problematic is when you can't recover from duplicate requests. Now in that case, you should consider using some idempotency solution like what I showed you here. Now let's move on to our next lesson, where I want to discuss how you can use webhooks for implementing server-to-server communication. When a client application wants to communicate with our API, it can send a request over HTTP and get back a response. When our application wants to talk with a third-party API, it can send a request and get back the response. What's important here is that both the client and our application know the destination where they should send the address. But sometimes you want to expose functionality on your REST API that's going to allow other server-side applications to subscribe to particular events of interest inside of your system, where your system can then notify these applications when this happens. This is what webhooks do, and we are going to discuss them as part of this lesson. Now, I have to make an initial remark that I will not be implementing support for webhooks as part of this course. This falls outside the scope of what I intended for pragmatic REST APIs. However, I do have a series on building webhooks from scratch on YouTube, and I'm going to leave the entire playlist as a link under this video. You can think of webhooks as events, but for APIs. We typically publish events over a message broker, but we can also implement support for events with APIs, except the communication here is still asynchronous in nature, but we are just using HTTP as our message medium. Let me explain with a diagram how webhooks function. So let's say we have a client application, which is typically a server-side application that has a fixed address that can accept webhook requests from our REST API. The client application is going to call some endpoint to register for a webhook. Our API is going to confirm this registration, and then sometimes in the future, this event that we have subscribed to is going to occur. Let's say that we subscribe to any time an entry is created, and we want to notify of this by the DevHabit REST API. So what our application is going to do is it's going to figure out who is subscribed to a particular event, and if they have valid subscriptions, then it's going to send a post request with some standardized webhook payload to the respective URL that was provided in the webhook registration. This should return a 200 OK response. Otherwise, we run into some alternatives, where if the webhook request fails, we may consider retrying it. Now, what kind of retry policy you implement is up to you. Typically, you'd want to retry the webhook, let's say after a couple of minutes, then maybe after a couple of hours, and possibly after 24 hours or a couple of days, and after that you may want to give up, and you should also consider completely disabling this webhook integration, but also notifying the client about that. Another flow that we should consider if we want to provide support for webhooks is validating the URL that is provided in the registration request. We want to make sure that this is a valid URL and that we aren't wasting server resources by sending a webhook payload to a non-existent address. So this is a quick overview of how webhooks work. Now, what are some practical use cases for webhooks? A good example of this is long-lasting requests, where we don't want the client to block and wait until they get back a response. Instead, the client can send a request and also provide a webhook URL where we can notify the client once the request is successfully processed or it's not successfully processed. We can decide to send webhooks for both success and failure situations. Let me give you a practical example where I have used webhooks in the real world. I was building a REST API that allowed the clients, which were other applications, to upload an audio file, and then I would transcribe this file, which could take a considerable amount of time, store the transcription, and notify the client if they have provided a webhook URL. It is up to the client system to decide what happens when they get the webhook request. Our REST API as the service provider should at least document what the request payload will look like so that the client knows what to expect. Let me give you another practical example. This one is from Auth0, which is an identity provider, and Auth0 allows you to define an action that you can run after something happens in their system. A typical use case for this is doing something after a user registers with Auth0, where you can define an action that can trigger an API request to your system. You could use this if you want to integrate Auth0 as an identity provider, where your clients authenticate and register with Auth0, but you also want to notify your system that the user has registered. You can create an action that sends a simple HTTP request to your API, and this essentially represents a webhook request that you are subscribed to. The Stripe API also allows you to subscribe to webhooks, where you can be notified when something interesting happens when it comes to payments. And with this, I'm going to wrap up this very quick overview of webhooks and how you could use them inside of your REST API. As I said, if you want to learn more about building webhook, then I recommend that you check out the YouTube playlist that I'm going to add as a link right under this video. And we can move on to our next lesson, which is about building asynchronous REST APIs.